Welcome everyone to this week's IPLD community and sync meeting. It's May 22nd, 2023. And as every 4 weeks these days, we go over stuff that people have worked on. But now what is new, we also have some talks. I think we should start with the talks first, and then get into discussions and any things we talk about, and then if we have time, we can still talk about things that people have worked on, because usually these days it's not that much that people work on direct on IPLD, but it's exciting to see what people use IPLD for. So I guess I hand over to Mauve, because you have some interesting IPLD things to share.
Yeah, hi. My name's Mauve. My pronouns are they, them, or it's. For those that are not in the know, I've been doing some IPLD stuff for a while. Formerly, I was kind of working for the IPLD team, but now I'm just in the ecosystem doing stuff. I didn't prepare any fancy slides today. I wanted to mostly just talk about this tool I made called car2dot and maybe look at how I did it. Hopefully this can also serve as a way for folks getting into the JS side of IPLD to know how they can use it themselves. Cool. So with that in mind, let me share. I'm going to be doing a bunch of screen sharing in little bursts. So hopefully my client doesn't crash, but it probably will. So first thing I'm going to do is show off just the end result. Is this visible for folks? Great. So here we've got a large car file representing a UnixFS DAG. And this got generated using a couple of steps. So there's this cool format called GraphViz, which folks may or may not have heard of. And it's usually used for creating diagrams, specifically flowcharts or like UML type things. But I generally like to use it for just showing things in a graph format. So the most popular, well, as far as I'm aware, engine for actually doing layout is this format called dot, where it's kind of like an ASCII text format for making graphs, where you can have, oh, am I still sharing? How do I, oh, there you go. Where you basically define some nodes and have like these little ASCII arrows pointing between them. And then you can add extra formatting if you want. So the way that gets turned into, the way that we turn car files into this is by, or wait, should I get into what car files are first? I don't know what the context is for folks. I might as well. So car files are content addressable archives. That's right, the R stands for archive. And it's a way to group a bunch of blocks in a single file. Usually people use this to export entire graphs of IPLD or UnixFS data, where as they're traversing through a graph, they will take each block in their traversal and write it in an append-only fashion to a file. And then at the end, there's a little index that says, hey, this is all of the blocks. If you have a given CID, here's the index where the block starts and ends. And this is how you can quickly do random access in the file to treat it almost as a read-only block store. So people use this a lot. Mel, do you think you could mute your mic for now? I hear a lot of clackety clacks.
Oh, sorry.
No worries, thank you. So this is used a lot for exporting files and data sets to something like Filecoin, or downloading a bunch of data at once from a trustless gateway, where you can verify data as it's coming in, or kind of like get a bunch of data at once rather than a single block. So personally, I use it in stuff like Web Recorder, where we're doing custom chunking, and we can take like a web archive, do some custom chunking on it, and then export it as a CAR file, which can then be imported into someone's UnixFS node or published on Filecoin. So sometimes when I'm doing this custom chunking stuff, I get bugs, or I'm not sure whether something is working exactly as I want it to. And so sometimes I wanted to just visually inspect what data looks like. So what the car2dot library does is it will iterate through each block inside a car file and traverse any links it has to other blocks and add them in this dot format. So, for example, I'm going to edit rather than doing slides. I'm just going to add text directly inline because it's easier for me. So, bam, over here is this horrible monstrosity of a dot file. So this is that diagram I saw earlier. So if you look into the details, oh wait, is this? Yeah, it's basically impossible to see. But there is a CID that represents each node in that graph. And then I either have a label having like a short form of the CID along with the size of the block in question. So this one is 151, which is pretty typical for UnixFS directory or file with just metadata. And so, for example, this one is a lot bigger. So that one's probably a raw leaf for a chunk in this archive. So this gets processed by a command line tool called dot, which comes with the graph viz tools, or you can use it with something like hackmd .io. And oh, oops. Where a lot of tools just support GraphViz out of the box. So if I do GraphViz, one sec, I can't. Yeah, I can paste my dot format and it will actually take, oh, it's really struggling. Did it work? There. Yeah, this is a huge graph. So sometimes it just
a typo there. So it's so in the graph is at the top.
That's a classic me moment. Thank you. Okay, bam. So this just rendered that entire graph in this little preview. So this is something that I use a lot for debugging, or say I'll have a bunch of little graphs that I'm viewing in parallel to kind of compare between what's expected and what's existing. And here you can see, oh yeah, this is just like a huge graph with like lots of stuff where I'm testing deduplication. But you can see how each level in the DAG kind of gets grouped on its own level. So here we have the root of the UnixFS file. Here we have some other file that's pretty large. And then in that file, it has chunks that are also large that kind of like go down, down and down. So this can be used with things other than UnixFS. So let me get another file into my clipboard so I can render it out. So.
Does it always strictly do the levels so that anything 3 deep will always appear in that third column?
It's kind of at the mercy of the layout algorithm.
Okay. So it may, depending on what space it's got on the screen, it may shuffle things around.
Yeah, so I mean, if someone has any car files for me to test out that have like weird connections in between them, that would be great. I personally have like very organized tree ones, but when you have deduplication in place, that's where you can have things kind of like pointing to each other. Another thing is you might have multiple roots inside a car file. All of the ones I'm testing usually have a single root with a bunch of data, but you can kind of see how the deduplication works, where multiple roots will point to the same content sometimes. Yeah, if someone even has like an IPFS URL for me, I could turn that into a car file on the fly. But maybe this could be a good time for me to segue into showing off how the CLI works. So let me stop sharing this and instead share my terminal. If I can, there it is. Is this legible?
Yep.
Cool. So so here I've got some fixtures testing IPLD polytrees. I have this car file representing my data. And in order to use the tool, you just need to have npm installed. I am contemplating publishing just binaries for the different platforms on the GitHub releases. But for now, you should be fine with just setting up npm. It's not that hard. Or you can import this as a JavaScript library. So to run stuff straight from npm, you can use npm and use --yes to auto accept installing, or just type the name of the package. So the package is called car2dot. And if I run it with no arguments, it just kind of sits there because it needs some sort of input. So what I'm going to do is use cat to start reading this tree.car. And I'm going to feed it into npx car2dot. And this will take the stdin car file, start parsing it out, parsing out the blocks in it, and then start spitting out the dot file. So what's handy here is that regardless of how your car file got written or what headers do and don't exist in it, this program will parse it on the fly using streaming data. So say you have like a car file that's like a terabyte in size or something horrific. You can have a multi-terabyte dot file, which good luck turning that into an SVG, but maybe you'd want to. But this means it's pretty fast to run this. This is like, I don't know what the command line arguments were for getting file sizes, but it's like a megabyte. So from there, I can feed that into the dots command line tool utility, or I can take the dot file directly. So here I fed it into dots and it generated this nice SVG. I can save it to a file. And now if I go back, here, it's easier actually for me to paste it into my clipboard. Oh. So now if I go back to my screen share, I have a lot of stuff open. So now if I go back to my screen share, I could just like paste the SVG. Oh, never mind. It can't handle that much. Okay, bye. So I usually just use DevTools for everything because it's just so much easier. Oh. Cool. So now you can see this is a Prolly tree with like a huge amount of data. But this actually has named links. So let me zoom in. I need to actually set it. There's a weird thing where you can't zoom in if you set your SVG file to be like inside the body. Whereas if you set it as the entire HTML, you can actually zoom in properly. I don't know. HTML is weird. But here, rather than using the weird like links from DAG-PB, we have actual names. So this is a Prolly tree, and that uses IPLD schemas to encode everything as tuples. So sadly, you don't get to see that structure very well. But if this were like strings or some sort of DAG seaboard data with like human readable values, I could see it there. Yeah. So one last thing I wanted to do is just kind of like dig into the code of how car2dot works, because I think it could be useful for people getting into JS IPLD. So one of the things with JS IPLD is it's kind of very spread out right now, where there's a bunch of old code, there's a bunch of new code, and it might not be obvious how to say go from the multi-formats repo to something actually usable. So generally, some of the libraries that you'll want to use is, of course, the multi-formats repo. And here I'm going to be using the block interface and some codecs for DAG CBOR and DAG PB. So one thing that I see a lot, which we really need to have a library for that's standard but don't have yet, is to have some sort of registry for codecs and a way to interact with them. So I usually just keep track of a map and just set a map from the codec code that you'd see in a CID to the codec itself. And I use that later here where I actually parse out data. So there's a library called IPLD car. And so this is how you can parse out car files. And it has a handy function called car block iterator, where you can feed it an async iterable of bytes, and it will parse it as blocks on the fly, and it'll yield IPLD blocks for you to actually consume in your application. So here I'm going to create car block iterator from stdin or whatever iterable you have. And then as I iterate through it, I fetch out the CID and the bytes from the block. Then I check whether the CID is using a codec that I recognize or not. And then I parse out the decoded value from the block using the codec. From there, I construct an actual block interface, because sometimes you want to traverse the data in a block in a high level way where you don't have to actually worry about like what specific data type it is. And the block interface gives you that in the form of the links method. So with this, I can traverse any arbitrary block and yield out data for my dot file. So this is just kind of like a useful thing. I feel like some folks don't use the block interface to actually traverse data inside IPLD. And this is just like a small reminder that they probably should. Yeah, but the entire file is like less than 100 lines of code, and the IPLD stuff is maybe like a few dozen. So honestly, you might want to just copy paste this for yourself in your own projects if you want to render out more custom views over docs. So we do have some basic CLI options. Namely, you can either specify the direction that you want the graph to be rendered in. Sometimes it's easier to to read it when it's top down with the root at the top and then leaves going to the bottom. Sometimes I like to have it set left to right, where the root is on your left and your leaves are on the right, so that you can scroll up and down to view through stuff. And you can set the title or the style. Not going to get into the styling, but there's like a whole bunch of stuff you can do. I added a default style because I think it's cool. Yeah, and then there's just a JavaScript interface for this, where you can import the car to dot function or the blocks iterator to dot function, and then you can just pipe it into readable streams or async iterators, what have you. Yeah, so that's pretty much all I have there. Any questions, comments, rambles?
Thanks. I think it's great to see kind of like a small example on how to put all those like multi-formats, codecs, whatever into something useful, because like that's really the hard part about currently using IPLD. So I think it's a great example to have.
Yeah, I can see this you adding lots of features over time and it becoming less useful in terms of pointing people to it. Go and have a look at that. And there's like one page of code of how to put it all together. But right now that page is actually really good because we do have people showing up saying, what do I do with this stuff? To being able to point to active examples of things that are compact but use all is really good.
Yeah, thanks. I mean, honestly, I'm probably not going to be adding that much more features wise. Like maybe I'll add some sort of metadata on like what type of node is in the graph. So like maybe say this is a DAG Seaboard node with like, this is the property at the top. But this is mostly just for traversing links inside the graph, just to see how the blocks link together. So I don't think it'll get too complicated. One other thing that I think is useful is just to like expose people to the idea that maybe you don't need all of like an IPFS node in order to do stuff that's like IPFS related. Because car files and some codecs and like just reading them from somewhere can get you actually really far. So before you even get to libp2p or like Kubo or like whatever other fancy features you want.
Yes, I agree.
Do you have a mode where like that deals with rootless cars? Because that's something that we've encountered a couple of times, which makes it tricky to visualize because where do you start from?
Yeah, so that's the cool thing here, because like usually people think of reading car files. So like just for context for anyone watching this that's not aware, car files usually have a set of root CIDs in their header or footer, one of those, where this kind of says like, oh, this is the DAGs that we're representing here. And services like, I think Web3 storage, I think they require having roots set on your car. And usually that's what's used to traverse the data within it. However, in this case, since I'm just iterating over the blocks in the car file rather than traversing the DAG itself, you can have whatever data you want. And in fact, if you have a node that's linking to a block that isn't in the car file, it actually doesn't matter because the node will just get represented as like a virtual thing, just due to the way dot works. So you can have as many or as few roots as you want. Doesn't really matter because it just looks at it one block at a time and just uses the links function from the block interface to get a list of edges.
So Dot's really doing the heavy lifting here of figuring out how to organize it, because that was a lot of my questions was how do you deal with that organization? Do you have to buffer? But really you don't have to, you just spit it out and Dot will organize it for you. Yeah,
exactly. GraphViz is a super useful tool. One thing I also want to experiment with is other formats that GraphViz supports. So Dot is really used for more hierarchical data or like flow diagrams. However, GraphViz also supports ways where it's like more of a physics directed thing where you can just have a swarm of nodes and it uses physics based layouts to kind of like position them in space. So rather than like a top down, it's just like a inside out. And that can be useful for finding clusters. Or say you have like a very large data set with very complex interlinked data between it. This is how you can kind of visually inspect where stuff is grouping or not grouping. But that's like a maybe later feature. That might be like a separate library because I think GraphViz has different names for the different layout engines.
So I talked on the channel, we'll call it the channel, it's bridged everywhere, about Unix FS names would be great in here because the majority of the data that you're going to be putting through here is going to have links /number/hash. But I think it should be pretty straightforward to just, you got to detect whether A, it's DAGPB and it is Unix FS, and then B, for each of those links, just replace it with a name. But then I guess you'd want a separate mode then, like -- IPFS or -- Unix FS or something, so that you explicitly opt into sort of obfuscating the IPLD nodes with names. But it would be really nice to be able to see how has my Unix FS data been chunked, and be able to see my directories and see it all chunked up. That might be really, really neat.
Yeah, this might also be part of the implementation of the block interface, because I'm not sure whether the block interface handles DAGPB in any sort of special way. No. Like, honestly, Unix FS and DAGPB are just this like huge elephant in the room whenever anything IPLD gets mentioned. Because like just today I was on a call with someone and they were like, I'm so confused. I'm using IPLD resolve, but it's giving me this like weird object with links in it, and it's not actually traversing through the links that it's supposed to. And it's like, yeah, that's just the norm. Good luck.
Yeah, in the Go world, where I'm doing a lot of this stuff, it's actually solved really nicely with ADLs. Like, it's actually working for Unix FS really nicely, where you just shove it in this layer, and then everything just works, including sharded directories, all that sort of stuff. And that's really nice UX to not have to worry about all that stuff.
Yeah. I really wish there's also like some way to specify lenses or ADLs or whatever inside like the CID or the block metadata. Because, for example, I mentioned that polytrees example. It looks horrible because it's like, what is this /0/1? Like, what does that mean? It would be nice if it would be nice if I could like apply a schema or similar. But that's like if tooling supports it someday in specs, which I guess we'll see.
You could potentially do that if you smash if you take the data and the schema and you smash them together in your utility. You could probably make sense of some more of the data. So you take the tuples and turn them into structs, and you can give them names and things. But it would be quite a bit more overhead to have to detect where you are and what you're looking at.
Yeah. So yeah, if someone desperately needs that, hit me up. We could do a support contract for this like enterprise grade utility.
I had a this is not a deeply serious question, but I was interested in the way that you shortened the CIDs. So you're going from the left, you're taking off the first 7 characters. So getting rid of the common, Baffy, Ray, Baffy, Bay, whatever. And I was wondering if was just an arbitrary choice, or do you mentally identify CIDs from the left? Because I mentally identify them from the right. I look at the last bit of a CID when I'm trying to remember that CID. I look at the last few characters.
Yeah, I mean, honestly, it's I think from both sides.
Okay.
Because like sometimes depending on where I'm scanning from, so I like to have both, because also if I only do on one side, sometimes there's like collisions and I get confused and cry.
Yeah.
But yeah, I literally just like looked at the CIDs I had. They were all CID v1. So for CID v0, I have no clue. I guess this will make the formatting super confusing. But I just like copied the header I kept seeing. I think Baffy Bay is
you're right.
Unix
That's
FS.
like 7 characters for CIDV1. That's about right. Yeah, it's just interesting the way people mentally do this, because I think we all do it differently. And
yeah, I've also been playing around with raw CIDs more, which is kind of fun. Because then you can just like read the data in the CID itself if you like bash your brain enough.
I mean identity CIDs.
Yeah, identity CIDs and the raw codec.
Right. Yeah.
Old hash, you mean?
Yeah, the raw hash. Or no, identity
raw multi-hash
hash.
with any codec.
Yeah.
Or
exactly.
is the identity hash? I don't remember which hash, but yeah. Somewhat relevant and irrelevant at the same time. There had been interesting conversations at IPFS, I think, a couple of months ago about how like inline CIDs with a raw hash or identity hash are kind of really not great. And we really need something like an inline blocks. I had some interesting conversations with Fission team, and we kind of wanted to drive some effort in there, but I think nobody actually did anything. But the main takeaway for me was that using these inline CIDs really messes up with the tree, because suddenly it's not it really prescribes you hashing algorithm now, while in most other cases it doesn't. And it would be nice to be able to decouple it. So there was also some relevant discussions around BAO and Blake tree blobs that IRO is using and how IPLD could look like there. I don't know where I'm going with this, but I would love to explore the inlining blocks without necessarily forcing them into a specific CID format.
Yeah. So in the web recorder custom chunking stuff we were doing, we actually experimented with using raw blocks inside identity CIDs just to like save on graph traversal. And what I found is that immediately my code for reading from a car file like broke, because it's just like, I don't understand what the hell this CID is. There's no data, cannot read like undefined of whatever. It kind of puked on me. So I had to add this like extra conditional where it's like, if the codec is, well, actually the codec being raw doesn't matter. I have a bug, haha. more of this being confusing. But yeah, if the cid.multihash.code is the identity, then I just return the digest. I
have similar code somewhere. Yeah, you
this is the thing that
I have exact same thing.
This code needs to be in every layer that manages blocks. So every block store, everything that where blocks flow through, everybody needs this, which is why they're such a nightmare, because any layer that skips this will end up causing you problems because, oh, I don't have that block. Yes, you do. I just gave it to you. That's the situation. I'm asking you for a block, and I actually give you the block to give me back, and you say, I can't find that block. So yeah, identity CID is a nightmare, but as long as you handle them properly. And the thing about the cars is that they don't need to appear in the cars. So if you're ever creating this, you don't need to put the identity CIDs as a separate entity in the car, because they're already in the block that they are referred from. And unfortunately, that's not enforced anywhere. So it's pretty common to see cars with identity CIDs as separate entries. So
Wait, how do you even place them in? They're not blocks.
So they're already in the block that's referring to them, because by referring to an identity CID, you're including the data. So
Yeah.
it's like a skip within the block, and so you don't need it. It's there, and any block store that you go and ask for that block should be able to say to you, here it is. Here's what you asked for. You gave it to me. So yeah, cars shouldn't need it. It's wasteful, and it makes code like this unnecessary here.
I mean, more like literally, how can you put them in a car if they're not like?
I
There's
think
no
what
way to
Rod is
just.
saying is reader get here should do that boilerplate for you.
Oh, yeah.
Yeah.
Like it seems just like anywhere where there's a block store, it needs to handle identity CIDs,
Yep.
and everything that is a reader of blocks should have like a block store spec. I think this is just a case where it's like, oh, we're a car reader, we're not a block store. Haha, someone else will deal with that at the block store level. Which I guess, yeah, I don't know. I'm glad you've complained about this before, and that's why it was easier for me to debug this when it happened. So thank you.
I spent a lot of last year doing this in Filecoin, so just basic Filecoin stuff, where it turns out that we weren't handling identity CIDs properly, and so all these bugs kept on appearing of people couldn't retrieve data, people were getting mismatched commitment CIDs, all because of identity CIDs, and they just create such subtle bugs. So I'm not a fan. So.
I also tell everyone, please don't use identity CIDs. Just don't.
So I also did last year. I also did some work on what the break-even point for identity CIDs. If you a lot of the use for identity CIDs is I want to save space, and there's a break-even point depending on how you're storing or transporting them. And so I have a graph somewhere on GitHub of like cars with and without identity CIDs and where the trade-off is. And it's pretty short. Identity CIDs don't need to be very long for them to become pointless in terms of saving space.
But for us, use cases had been not necessarily about space, more about the locality of blocks. If it's identity, it's there. If it's something else, it may or may not be there, which imposes certain problems. So that is why I'm saying, like, I would love us for having another format where we can inline a block without making it identity CID. Ideally, it would be actually whatever CID the block is, I just want to include a block in there.
That would be a codec thing though, wouldn't it?
Yeah, I think so.
Yeah, for anyone curious watching the live stream, this is the dark magic for how to make identity CIDs. So first you import bytes from multi-formats and you get effectively a byte array. Then you use the cid.create method. I use version 1 CIDs all the time. You also need to import the raw codec and the identity hash. And so you take the raw code, or this is if you want to store raw bytes in an identity CID. You might want to store encoded data, but that adds extra overhead. I usually just store raw data to save on extra bytes. Anyways, you feed your raw bytes into the identity.digest. And I think that does like some extra encoding. I'm not 100% sure.
Just multi-hash, yeah. It adds the multi-hash prefix stuff to it.
Oh, there we go. Yeah. So this is how you do this illegal code. So if you add this all over your code base, you can give Rod extra headaches down the line.
So you make headaches. No, I mean there's a certain amount of fun in having to handle this weird edge case that has legitimate uses. Like it's not like this is hacker stuff, but it has legitimate uses. But you have to handle it. Everybody has to handle it properly for everything to work nicely. And so when it works, when it's all working, then it works great. But it also creates sort of these cognitive. I find it creates cognitive barriers especially when you're trying to explain it to people. So it's hard enough
Yeah,
explaining this.
It could be that maybe integrating it properly, the multi formats library layer would alleviate most of the issues.
Yeah, maybe special casing it and having utilities especially for it would be a good idea.
So in our code base, we have a like dog.js module, which basically does a like reading stuff and decoding mostly for you. And that's where this kind of little snippet if we have there. So if it's identity blocks, then it kind of does a shortcut for you. And that kind of removed all of the edge cases for us because everything goes through that dog.js and then kind of deals with it. Yeah.
Okay, well, thanks, Mo. That's been really, really good. I really do like that it's the short amount of code that uses a lot of the surface area of the APIs. So it'll be good to point people to it.
Yeah, thanks. I mean, thanks for everyone making this code usable. It's pretty good. It gets the job done. Folks should look at it.
Cool. Yeah, thanks. I've seen that Rod has a few updates. So, or does anyone else want to chat about other things before we get into news from the core development?
I'm somewhat curious. Mo mentioned earlier, using custom chunkers and stuff. If that's not too long and can be squeezed in, I would be curious. Partially because I've been doing some, or I had to rewrite some of the Unix FS stuff that included the chunker.
You're muted, Mo.
Yeah, sure. I can get into it briefly. So the TLDR is I'm actually not using the chunker interface at all because it just is not flexible enough for our use case. What I'm doing is I'm instead using the what's it called? IPFS UnixFS module for encoding UnixFS blocks manually, and the IPFS car module for encoding it into car files, and the IPLD/UnixFS module for creating writers for UnixFS data. So the web recorder use case is like kind of subtle, where we have this file format called webarchives.work. Effectively, it's a zip file which contains sorry, we have the waxy file format, the web archive zip file format. It contains a work file, which is a bunch of HTTP request response pairs in an append-only file, which contains like the archive of web crawl. And then alongside it, there's some indexes and some extra metadata. This all gets put into a zip file and sent around. So one of the things we wanted to do is to have aggressive deduplication on HTTP response bodies. And so what we do is we have a custom chunker for the zip file itself, where we take the zip file and we turn each individual file within it into its own UnixFS DAG. And we manually stitch the subdags together at the UnixFS layer, where the point is that if you have the raw file from the zip file somewhere on IPFS, you'll be deduplicating the storage for that and deduplicating the peers. The next part is in the work file within that zip file. So it's its own UnixFS file that's sharded. We take each request response pair and turn it into its own UnixFS node, where we can use this to like remix work files by just zipping these pairs in whatever order we want, or like adding and removing them between archives. And then for the response portion in particular, we find the boundary where the response metadata starts and ends, and we take that chunk of bytes and we feed it into the default UnixFS chunking algorithm. So this IPLD/UnixFS library has this create file writer method. and that takes the usual like chunker options. So we're just using whatever the default is in IPFS UnixFS, but you can customize it so it aligns with Kubo or whatever else. But the idea is that that response body, if there is any other response that has those same bytes, they'll be chunked as though someone uploaded the file to IPFS. So say it's like JavaScript assets or images or what have you. It means that we can have very aggressive deduplication of content between everything. So as I mentioned, we're not using the custom chunker for this. We're using just like pretty close to the metal UnixFS, where I'm literally just assembling UnixFS nodes in memory and then writing them as blocks to the car file. Yeah, so I don't know if that's like similar to your use case, but I found that that's way easier to do than having to like use higher level libraries like the chunker interface.
Oh, no, that's fair enough. Oh, so the IPLD UnixFS library is the one I was referring to, which has its own chunker interface, which basically takes bytes and gives you like sizes of chunks. But yeah, I think you probably need more knowledge about the data maybe to do the chunking there than what that would give you. But I'm not entirely sure.
Yeah,
yeah,
exactly.
It's very domain specific. So
I think the chunker is great for when you have just like a file you want to have into like even chunks or whatever, but like very content specific stuff, I found it's a lot easier to kind of, as you're parsing your data, just send those bytes into this car writer using like regular UnixFS writing utilities.
It's really
if you want an in-depth discussion about chunking algorithms, then Reba is the one to talk to, because he spent like 6 months doing a research project on possible default chunker replacements for IPFS. He's got a whole lot of stuff about different chunking algorithms. So
yeah, honestly, this sounds more not even a chunker, but like pre-processing the data into files and metadata that is separate blocks. I don't know if that makes sense, but I don't think it's even a chunker. It's something before chunker gets to play.
Yeah, we're doing like dark magic with UnixFS. This is like probably folks were not imagining this, because the other thing, just if I may, that's really cool here is the entire thing is just one UnixFS file node. And the way file reading works, it just kind of like automatically gets zipped up on the fly as you're loading data. And what's more, one of our apps, archiveweb.page, what it does is, in addition to taking those zip entries and turning them into a IPFS file node, they also add those very same hashes for the individual file trees to a UnixFS directory. And then they zip that together, where here's the waxy file, and then here's the raw directory view.
Oh, that's clever.
And then that all gets turned into a single thread. Yeah.
It is a chunker though, isn't it? It's just a very specialized chunker, because it's a single file as the zip, but the chunks are the different components, so that, yeah, that's very clever. And then there's a directory as well. I like that.
Yeah. We have a spec published.
That is dark magic.
Yeah. It's pretty hardcore. But it's not super hard to do if you struggle for a long time. Yeah, so if folks are curious, our spec is published on GitHub. This is actually being done through a grant from Filecoin Foundation.
Nice.
Well, mostly my interest was like, if there's anything about IPLD UnixFS that needs to be improved to make this easier, I'd love to do that. It's kind of...
It's great.
Well, the fact that Web is importing both IPLD libraries, UnixFS libraries, suggests that there's some improvement there.
Yeah, well, the bit that was kind of hard is that I needed a way to just construct raw IPLD DAG nodes, and the the higher level library didn't really have an interface for that, where it's like it didn't have a public interface for that.
Yeah. We can expose it probably because it has under the hood, since it's building the UnixFS stuff. Yeah, maybe let's chat
exactly.
it offline, and I'm happy to like provide whatever's needed, so you don't have to juggle between multiple libraries, if that would make sense.
It'd be really nice to stop using old stuff and use new stuff. Cool. I want to segue straight into something that at least one of the things I had on my list, which is so with the work that I'm doing on data retrieval, part of that was messing with UnixFS, because we do a lot of UnixFS past retrieval. And so one of the things I did a while ago, and I improved recently to make it publicly available, is some UnixFS file and directory test data generation utilities. And so I put them in, they're in Go, but it's in the Go, if you go to GitHub, IPFS.org/Go UnixFS node, there's a new package in there called test data, and it will generate for you all the variations of UnixFS trees in IPLD blocks. So you can ask for just single files, you can ask for sharded files, you can have directories, sharded directories, and it'll create these synthetic directory trees that have realistic names and files that have realistic names, and they can be really deep. And then you can do stuff with them like graphing. It'd be great. I actually was thinking about some of this data because some of it's really deep. It'd be great to stick them in the graphing tool and have those UnixFS names come through. So like one of the recent things I did was actually make them is do the realistic naming thing and have a library of words that it picks from, and so anyway, so that's that. I think that could be relevant here for anyone that's messing around with UnixFS. I found it really helpful in order to test some of the edges of interpreting UnixFS graphs and doing the ADL stuff that we're doing to traverse them.
Thanks. Yeah, so we are almost at the hour. So I guess if there's nothing else urgent, I will close the meeting and say that the next meeting is in 4 weeks, which is then June 19th. As always, so if you wanna, so also like if people are watching this and also want to talk about things or present things, then please, reach out to us. We are on so there is an IPLD channel in Slack, Discord, and Matrix, and so you will find us, and then reach out to us, and we are happy to have other people present. And all right, so and it's every time we still at least 1 minute we have an after party, so if you have something to share or want to say but not publicly screamed, so just stay on. I will stop the live stream and then we hang out for a bit if there's anything else, and then all right, so see you all in 4 weeks. Bye.